whenever I first, was talking about, whether to test APIs, web services, or whatever, I guess my question to most people when we talk about testing APIs is what is it that you test exactly, right? Do you test APIs or web services? Is there even a difference? Does anybody know what those differences are? Anybody want to take a shot at that? So whenever we're talking about APIs, APIs is any application program interface. One of the things that we want to remember is basically we in testing seem to use the term API as being ubiquitous with a web service or a web API. So some things that we want to remember when we're going through and we're testing and we're talking about these things is to remember that every web service is an API, but not all APIs are web services. While a web service may use REST or, God forbid, SOAP or XML, an API can use really any sorry, I mistyped there, but may use any communication method. So, that can be a direct library, that can be a jar or a DLL or whatever. It's any way that we talk to an application. And a lot of times a true API is accessing functions and methods and classes within that application directly. Whereas when we're talking about web APIs, it's effectively a REST, HTTP wrapped web API. And so web service will always need, or web API will always need a network connection, while an API may be directly into the package or whatever. So when you get asked, do you have API testing experience? As a general rule, in those interviews, the interviewer or the person talking to you is asking if you have if you know how to test and have experience testing web APIs or web services. So I'm going to be saying APIs as we go. And as I'm saying that, today, for all intents and purposes, we are going to be talking about testing web APIs or testing web services. But most likely, they are not going to ask you to test APIs such as your jars or DLLs directly. But don't rule that out, right? So if you are talking to somebody in an interview or whatever, it's not a terrible idea to clarify what exactly are you testing, right? Because you can say, yes, I've tested REST services, but that doesn't mean that they may have all SOAP and WSDL, right? Or they may be talking about testing, an actual application interface itself. So it's a good idea to kind of clarify that. It also shows the person that you're talking to that you know what you're talking about whenever it comes to testing APIs or testing web services. So again, for all intents and purposes today, API equals web APIs. So if I say that, that's what I mean. And that's specifically what we're going to be talking about today. So the reason why, I called this chasing APIs is because we have APIs at all levels of our stack, right? We've got some of those are, feeding our front end. You may have externally facing web services that are consumed by public or consumers, maybe other teams. They're writing to databases, they're reading from databases, like they're everywhere. And especially as we get to service-oriented architectures and microservice architectures, being able to test these is the best way. Because for a long time, we were doing, and really at the manual level, we're constantly like putting something in the front end, and we have this issue right now at ESO where we don't have tests along the way, right? So we have somebody will put in data into our electronic health record front end, and that goes through a couple of different cycles and iterations and transforms. And then all the way on the other end, we have a couple of analytics and database reports that, there's a series of service hubs and service buses and event hubs and all this different process that goes on. And what we want to do is we want to get away from using especially front-end automation to feed data in, wait for it to go through this entire pipeline, and then pull it out on the other side and verify it. Now, that is a valid test, right? Anyone who says end-to-end testing isn't useful or is dead is not necessarily accurate. That has a place, but it should be a very small percentage of our tests. So what we want to do in a lot of cases is we want to focus on just the individual pieces themselves, right? So we have, in our example, we have an EHR front end, we have a web service, obviously, that it talks to, and then a database. So we want to be able to use our automated tests for UI to cover our actual JavaScript interactions, the things on the page, that kind of thing. We want to then use, for our data input and validation, we want to write those into that service. It maps to the database, in which case at that point we can query that database to test that it was saved correctly. We can verify that it has output successfully in that or the next web service. So what I would suggest doing when you're looking at kind of this giant vertical stack of data flow is to cut it into the smallest horizontal pieces to test those specific things. So we want to test like the front end interaction. We want to test the web service to the database. We want to test the database to the, what we call our internal API. We want to test that internal API to our intake engine, et cetera, et cetera, et cetera, et cetera. So, and if we break those into small horizontal slices, we pack those full of unit tests and functional tests between those two pieces, the integration test there, then we can have a whole lot of confidence, even if we only have 1 or 5 end-to-end tests that follows that all the way through, we can have a tremendous amount of confidence in that data quality going forward. So what we're going to look at today is basically 3 types of testing web APIs. The first one is data contract testing, which a lot of this gets overlooked or it gets done manually. But there are a couple of tools out there that will allow us to do data contract testing. Testing explicit cases, and then version over version testing is going to be the final strategy we're going to look at today. So when we're talking about testing any of these things, there's a little bit of confusion on the market, especially whenever you're new or you've only tested using Selenium. What is kind of the best way to do that? So we have these GUI-based test tools such as SOAP UI, Postman, API Fortress, etc. And there's more of them coming on the market every day. Mabel is starting to get into the API web service space, and so it's good to see those come on the market. And so there are definitely pros and cons to those things, right? Generally, especially if you look at Postman and API Fortress, I haven't looked at SOAP UI in several years. I feel weird that it says SOAP UI, even though we hardly use SOAP anymore. That's just a pet peeve of mine. But I guess, why rebrand whenever you have something that works? But anyway, that's I digress. But anyway, there's a low barrier of entry generally to writing these tests, right? You set those up. In a lot of cases, it's point and click to set your assertions and all that. So it's generally low barrier of entry. You also have really snazzy reports. These things look really great when you're showing people outside of the team. And it's a good way to kind of visualize your tests. Also, things like SOAP UI and API Fortress as well. I think Postman does also, but they provide additional features such as mocking, load tests, all these different things that we may or may not use. The only kind of downside to those is like not many of them are free or open source. So generally there's a cost associated with that. And some of them have a free version, like Soap UI has a free version, but there's a paywall to get to some features, right? So you have access to some of it, but you don't have access to the full suite or can't integrate it with your CI or something like that whenever you're using their free version. So there, there's pros and cons to that. One of the things that it does as well is gives us less control because we're working within the bounds and the confines of those tools themselves. So in our case, I put this gear as bigger here, not because it's necessarily better, but that's because that's what we have chosen to do. So this is your using REST Sharp in the C#.NET area, REST assured HTTP request in JavaScript. So we went this route for a couple of reasons. First of all, it gives us complete control of our test setup. So anything we need to do, like we have some pretty complex to even get to our services. And as we get more and more like centric on like security centric, and especially in kind of the medical space where we need to have things kind of under lock and key, we have tokens that we have to grab along the way to be able to make these requests, so there's not cross-site scripting requests and things like that. And so that's something you could do in some of these, but because it's a lot of dynamic cookie and token generation, and sometimes that anyway is difficult to get to on purpose. It makes it difficult with some of these kind of GUI-based tools. Now, if you are using like the example service we're going to be looking at today with our code examples, if you're using something that's front-end facing and it's completely public and you don't need OAuth or anything to get to that, then it may be best to go with Postman and Newman, for your Jenkins stuff, or API Fortress or something like that. Because it lowers that barrier of entry. We also have more control over data manipulation and mocking if we know that we can create these records. We can edit those records and make changes to them, and then assert on them. That is really easy to do when we're doing that with code. So again, if you're making if you're not doing that and you're just basically going through and saying, I want to test all 1 million records in my database, and all that's easy to get to, then you can look at a GUI-based solution. But again, for us, code makes more sense. Also, it's open source, and well, depending on your framework, but basically what we find is it's easier to budget time than dollars. So when we need to go through and make a request for a tool, it's just sometimes it's easier to just code it. Also, though, you may have heard of the law of instruments, right? So when you have a hammer, everything looks like a nail, right? So the fact that I'm comfortable with more comfortable actually writing code, and this is a lot of the reason why when we were looking at Test Cafe and a few different things earlier, I guess it'd be a year ago or more now, and they were asking us questions of like, well, do you guys use record and playback and different solutions like that? And most people in the room said no. And it's because we are so comfortable writing the code that we almost don't trust anything else. So whenever you have a hammer, everything looks like a nail. But does that always mean it's the best thing? Not necessarily. So what happens whenever you try and hammer something that doesn't want to be hammered? Well, you get a bigger hammer, right? So that's always my solution is, okay, well, if I can't do it with code and it might be easier than somewhere else, surely I can do it with more code, right? And so that's always the trap that I fall into. And I'm aware of that. And so it's something to think of, to look at your team, just because you or I am really comfortable writing kind of automation tests, because I started that at realtor.com in like 2011. That's something that's relatively easy for me to do. Whereas you may have less technical people on your team, that a GUI-based solution might be better for them. So it's definitely something to look at and to go over your options whenever it comes to test tools. The key thing though is regardless of where you're at, use the right tool for the right job. We can make claims all day to go one way or the other, but really take time to understand what the right tool is and use that first and foremost. So now that we got kind of the tools out of the way, so again, we are talking about testing of web services or web APIs. We are also talking about using different methods of just code and REST libraries to do that. So that's what we're going to be using going forward. The only caveat to that is data contract testing. So I will show you in just a moment an example of using Postman for some of that data contract testing. So what is a data contract and why do we care, right? So the data contract is something that a lot of times we overlook when testing. We go in and we start testing each, specific fields. We make sure that there is, 200 requests or 200 HTTP code, that we're not throwing 500s or whatever, or 400 bad requests, whatever. But a lot of times, what really matters, especially if we're externally facing, or if there's teams that are consuming our data through those services, is our data contract. So the data contract is the compass that others use to navigate your web service, to get at your data, right? Which a lot of, like even ESO, the reason why we exist is data and getting that to other people. So it's very important that that data is in a way that they can use. So what is a data contract? Well, it's an agreement on a specific data structure, such as schema for a service and its consumers, right? So who uses the data contract? It could be any consumer of your API. So if you have complete control over your API or your web service, I'm just probably going to say API from here on out, but if you have complete control over that and you're the only one that consumes it, data contract may not be so important because you're the one testing very specific cases during that integration test. But the key thing is if we have third-party companies that are using that, or if we have another internal team that's consuming that API, the one thing we don't want to do is to break them because we broke our data contract. So when do we need a data contract? So anytime someone other than development teams want to use their API. You could also say all the time, right? Because as a tester, it's important for you to know what that data output is supposed to look like. When you know what that output is supposed to look like and function like, and what that schema is explicitly, then you can make better calls whenever you see changes to that data structure. So where can you get your data contract? This should be documented by the team or a product manager. If you don't have one, especially if some other teams consume that, that's a red flag, and it might be worth talking to somebody. In the past, we didn't have that from business analysts or anything like that. And so I was the one kind of building that data contract and taking it between our team and a front-end team that was consuming our search service. And so that's something that it may be important for you to do because it's hard for you to test the API if you don't know what it's supposed to output. So why should you care? So have you ever deployed a web API to production only to find out that it broke some third party, not necessarily the one change, one field you tested, but because of a schema change? Because I have, and I've seen that. So here's an example, and I got this. If you go to apifortress.com, and I bring them up because they came in and did a presentation for us. We like the guys over at API Fortress, but they have a couple of ebooks, and one of the ebooks they have is basically the 9 bugs that they find using API Fortress, and that's a really good read for anyone who is trying to think through their tests, specifically in regards to APIs, because all the tests that they found, or all the bugs that they found, can be found through code and other tools. So because they're very common things. But this is an example. So a large image company had an API that fed stock images to its customers, including a print-on-demand platform. So basically, this print-on-demand platform, allowed people to put pictures on hats and mugs or whatever, and all of a sudden they got a call because they're freaking out. what happened is the image provider's API team pushed a release, to clean up a few lines of code in the process, made a structural change, which most of their customers didn't affect. However, it broke that API. It broke the product for this print-on-demand service. So it was written strictly, and they were not ready to handle that change. And whenever they did, every time somebody would click on that, to use an image or to search for an image, it would completely break, which can have devastating effects to a company whose, revenue depends on that. So it's very important for us to know what our data contract is, how it affects teams that are consuming it, and what changed when we do, what changed whenever we make releases, right? So when we're testing data contracts, the first thing to do is to get the data contract schema. This can be done through product managers, business and product analysts, etc. It may just be you going and finding that information yourself. You can take current JSON, run it through a JSON schema tool such as JSONschema.net. Visual Studio also has plugins for this. Just be aware that if you are using something like a web tool to find your schema, which puts it together in a really nice format, just be aware of your security policies, any ramifications of data being saved. It's one thing if you have a publicly facing API and you want to get the schema for that. Anybody could take your, look through your inspector, so that's not as big of a deal. So it may be better to use something internal or a Visual Studio plugin that's not making external requests, things like that. So just be aware if you're going to use tools like that. I'll be talking about another one as well, but make sure that you know what the ramifications could be of that. You can also check self-documentation such as Swagger. One thing that I will say, and I noticed we had this a lot, especially at Realtor, whereas I was like, hey, what's the output? What's the schema for this endpoint? And they'll say, well, check Swagger. So Swagger is it shows what it currently is, not necessarily what it should be. So it's important to know the difference between where it was in the previous release and now. But you may say, okay, I know that right now we're in a perfect state. Okay, that's a good time to go check Swagger. But just because it says it in Swagger doesn't mean that's what it's supposed to be. So be aware of what those changes are. So determine your tool. In most of these, some code is required. You can use something that's complete code, such as Pact. Pact supports JavaScript, Python, and Ruby. There's some really great Medium articles on kind of how to get started with Pact in their data contract testing. Or we can use something familiar like Postman. And I'll show you how to do that. And then step 3 is obviously write those tests. So can you see my Postman, Evan? Can you see Postman up there?
Yep, I can see.
Cool. Okay, cool. So,
right.
Okay, so this is a way of doing this. We are using a data exchange. So if you ever want to just play around with APIs, you can just Google GitHub public APIs. And there's actually a repo on GitHub that has an entire list of just a whole bunch of public APIs that you can get access to. All of them are free and something you can get set up really easily. Most of them don't have OAuth. Like this one doesn't have any sort of authentication. But anyway, so if you're looking for that, there's a good way of getting a service, a web service to kind of play with. So in this particular case, we are looking at an output. I'm going to grab that, the body right here. So in this particular case, we have basically all the data exchange currencies for that day, with the base is the euro, and then the comparison off of that. So there's 2 things that are already built into Postman, two libraries that you can use. AJV is one, and then TV4 is another one. So basically, we start by determining what our schema is, and So this one I used the Visual Studio JSON schema plugin. You put it in one side, it gives you the output schema on the other. It will give you a lot of other things such as description, and even like this ID is not necessarily important for this particular test, but it does show you what the path is to that. So we always want, in this particular case, we always want all of these. We always want a date, and we always want kind of the base thing. And so when we run our tests, in this case, I actually made a change. So if you look here, HRK is supposed to be, according to our schema, a type of Boolean, but it is in the actual response body, it is a number. And so therefore it is throwing us an error. So if for some reason our data types change or something like that, it's going to throw that error. Of course, if I change it back to number and run it again, both TV4 and AJV passed. So basically how this works is you say PM test or postman test, and then what your validation is. In this case, we have our schema up above, PM response.json. And then in this case, we stringify the errors. So basically, when it shows us what our validation is wrong, yes, this is specifically contract testing. Yeah, or an example of contract testing. And then TV4 is very, very similar, right? You do TV4 validate results, pass in your JSON from your response, your schema, and then you hope that it is true, right? So this is a way of doing some sort of contract testing. It's really easy to kind of get some of these set up and save those. And so every time you make this request, it runs. And then you can also use Newman to run these in your kind of CI environment. I will see how much time I have at the end. So rather than doing questions on kind of data contract testing, we're just going to keep on trucking. Okay, so next we're going to be looking at testing kind of specific response codes and fields, right? So this is the most common type of web API testing that I've seen. If you go look through, you go through and look at SOAP UI, API Fortress, etc. A lot of those are going to be, things like make this request, check that it's valid, check that this is a number type, check that this has a specific output, etc. These are the kinds of things that we're doing. These tests are valid, especially whenever you're using like a service that should return, like a type of test, like you want to check that they're returning valid results, or specifically if I give an invalid input, that it should throw the correct errors. And when you expect specific output to be consistent. So if you have specific data that you are going to be testing, or like a specific record that you want to display the same every time, then that's really easy. Or if you are making specific changes, specific input changes in your data structure setup to those tests, and you want to verify those on the output explicitly, maybe there's a transform at the database level, or we have XML transforms all over the place. And so that would be a time when you would say, okay, I'm going to make this request to set it up, and then I'm going to go in and verify this specific output. So that's a way, that's kind of a really good use case for this kind of test. So there's two ways that we can do this. We can use dynamic objects, we can use deserialized objects, or a little bit of both. So what are dynamic objects? So a dynamic object is specifically the dynamic data type is specific to C#, and it's fantastic. It basically works like an object or class, but it is ignored at compile time. So you can take your JSON output, you can do a JSON.parse into that dynamic object, and then you can traverse through it pretty easily. So dynamic objects are great, specifically when we need a few key fields or when we want to write a method to get that specific data. As long as you can parse an object to the dynamic type and get the path, correct casing, etc., you can access anything within that JSON payload. So the pros to dynamic objects is like they're very easy to work with. You don't have to worry about them on compile time. We're going to talk about deserialized objects that have IntelliSense. These don't necessarily give us that IntelliSense. Dynamic objects don't require a bunch of classes. With response changes, you can just put it in there, access it, override it, access it, and you're fine. One of the things about this, and the same with the deserialized objects, is every field requires assertions whenever we're doing our tests, which can be very tedious. And if anything changes in the response that we don't have an assertion on, we won't be able to catch it, right? And so that's kind of the main thing with this kind of testing like status codes in specific fields. With dynamic objects specifically, it's really easy to use, but it's not necessarily easy for the person coming behind you to do those tests. I've got an example here of using some of these objects. So in this particular case, all this is going to be on GitHub. I have all this put up there so you can grab it, as well as this. If you're wondering what this request request is, that's just a wrapper utility object that I have, a class that I have, so you can feel free to take a look at that and use it as needed. So this is an example of just checking that it returns us an error code of 200. So I would say that this is not necessarily a great test, right? Obviously, we want our test to have status okay, but it's not necessarily testing anything other than the fact that it's not just heinously broken. Now, there could be, like, if we, in this particular case where we edit the endpoint, we know we want that to return a 400 bad request. So that might be an example why we might want to do that. But generally, these are not great tests because they're not very explicit and they don't test very much. Although they are granular, so you may or may not use those. But if all of your API tests is I make a request, is it a 200? It's not necessarily a very good way of testing. So what we want to do if we're going to go this route is we want to specifically test those changes. So let's say we wanted to make sure that the date is correct in this particular service. We're actually going to use the same one, the exchange rates API, 2010-01-14. We make that GET request. We then parse that into a dynamic object, which I'll go ahead and debug that test for us. Test with dynamic object. Now, obviously, tests are going to generally be a little bit longer than these and have more assertions, but we have, we should have access to that. So, in this object, we have rates, we have our dates, we have this set up just as if we had kind of a deserialized class. The main thing we want to do is, for example, we're going to make sure that the expected equals the actual. But for example, if you do a capital date here, or if anything is wrong with that, there's no IntelliSense to it, as well as you have to parse things to specific data types. So for example, if you are using, as this next one, this is a, not just a straight int or a string. We want to validate it against the double type. So we then have to parse that to a double. And so again, if this was a capital R, or if this was lowercase CAD, or any sort of casing issues in that, this would throw no reference exceptions because it can't find them. So again, if you have it, the first time you set it up and you're not going to make changes to these, that's fine. It's definitely something you can do. But there is kind of an easier way of reading those tests. So, and this could be hotly debated, and I'm definitely up for having that discussion, but specifically to use like a deserialized object, right? So we do the same request at the beginning. Actually, let me switch back to this. So again, we're using deserialized objects, which allow us to explicitly specify how we want our object structured. Again, it gives us, allows us to navigate objects and responses using IntelliSense. They are checked at compile time. It makes it quick and easy, especially for new people if they're not familiar with your service and with your application. It makes it very easy for them to access that. And be able to write new tests and make new assertions. So again, they're probably the easiest to work with in my mind once you get the object set up. They're easy to understand and allow us to use IntelliSense. It runs the same kind of issues as the dynamic objects, and that if we want to assert on a field, we have to do it explicitly. If anything else changes that we're not looking for, then it's not going to catch it. So similar to the JSON schema, you can use tools to get your dynamic objects. There's a couple linked here that you can check out for both C# and POJOs, plain old Java objects. So that's a way that you can do that if you so desire. And what that looks like here is we have we actually have a currency rate by date object. If we go to that definition, which we have them here, right? So in this case, we have rates, which is a dictionary. We have our base, and then we have a date. We have some stuff to actually convert that, to deserialize it from JSON, serialize it back to JSON if we need it, and do some conversions. So wrong one. So here we have the rates object. So similar to this, except for the fact that when we are looking for this, we can hit rates object dot date or base or rates, etc. We have that in our IntelliSense. It makes it really nice and handy to work with. And all we do is we take the response from the REST request, we put it in this currency rate by date from JSON, and it parses that for us. We also have access to that, rather than having to parse this to a double like we did before, and make sure all of our casing is correct. We can just look it up in our dictionary and assert on that. So that's an option for doing these for sure. So which one should you use? Well, probably a little column A, little column B, right? So specifically how we use dynamic objects is for test data setups, data lookups, for querying an API, I want to grab a specific field, something like that. So especially like, for example, if you have a bunch of properties, you are going to go over and search for 1,000 of them. We might just use a dynamic object to grab all of their IDs, and then we want to go look at the output of those IDs and on its listing details. It's what we did a lot of times at Realtor. So we could just go through a whole bunch of data. We would use our dynamic objects for that, and then probably a deserialized objects for our validation response. I'm going to show you an example of what we do specifically at ESO in regards to this. So we have in our electronic health record, and we're going to put in a primary impression. When we put in our primary impression, let's say Evan called the ambulance because he has explosive diarrhea, and so they're going to put that in here as his his impression. Now you would think that it would just be as easy as just storing this and saving it with its string, right? Unfortunately, it's not, because every agency can go through and change what all impressions show up in this list. And so that can change dynamically. And so we have what we call a bundle for that. So when we actually save Evan's diarrhea, it has a value of its ID, which is 10659. And it basically makes a request to save that data. So where do we get that from? Well, we have this giant output here, which, if you can see at the bottom, has over 96,000 lines. So it's an incredibly large JSON document that we have that's displayed. So when we're writing this test, we don't make these data save changes from the front end. Here, we are going to use the web service to do that. And so we have a utility. We take this entire object, so this massive, massive object. We then put it into, let's see if I have it up. I'm going to bring that up for you guys. But basically, we are going to take that entire object. We are going to store it in a dynamic object. And so we only need to call it once for this particular record. Let me make sure I got the right one. We only save it once for this particular record, and then we have access to that. We can make requests on that, and we can basically search for it. So, for example, we have, bring this over. So we're saving this as a bundle. So bundle data is a dynamic object. And that's so we don't have to have a massive JSON document in our deserialized object. And then basically what we do is we have get item from bundle. It goes through and it grabs this. So specifically we do list name, and then we grab all of its values. And so that's all of the units that are associated with that. And then we basically loop through those until we find the specific one we're looking for, and then output those. So then we actually build our request, which has this ID number, which again can change, and then we make that request. So this is an example of basically using the dynamic data to set up everything, to grab all the IDs that we need. But then in this particular case, our actual response object that we create, we use the ID from that dynamic object, put it into a deserialized object, and then make the request, and we can make any changes we want to on that request and on the field that it sends. So obviously, so there's a number of ways you can skin this cat. And so I would suggest kind of looking at what options are available to you, what works the best and what doesn't. If you have any questions about like POJOs or C# objects, if you're in JavaScript, all you have to do is save a JSON file. And it's already a JavaScript object. That's the whole point of it. So that is a way for you to be able to do that. One of the things, though, as I mentioned before, and this is kind of my mantra of all things automation, is automation can't find what it's not looking for. So let's make it look for everything. Maybe we want to know everything that has changed between versions. And so what I call version over version verification, or a data comparison verification of the entire object. So what is version over version? Well, it's a great option because in most of our cases, our data contract should be relatively static. If anything changes, maybe a calculation or schema, we need to know about it one way or the other. If it changes and we're expecting it to change, then we actually want to see that come through and verify that it did change the way we want it to, right? In which case, that's effectively our new baseline. If it changes and we weren't expecting it to change, then it's a bug, then it's a conversation that we need to have, right? So it implicitly validates schema, because if the schema changes, we will know about it. It validates calculated values. It validates positioning accounts, which sometimes matters, sometimes doesn't, depending on your consumer of your API, specifically positioning. It's very easy to set up new tests, and it's very easy to read the output. So basically, we take our previous release version, we take our current release version, we compare the two together. So you could do this from a previously saved JSON document, which is what we're going to show in this example. And then you basically take your current data from your web API. You make those requests, you compare them and get the output. So that's great. Or one of the things that I've seen this work best in, particularly because you can use large swaths of data very quickly, is let's say you have api.test.com. That's not a real thing. Don't go there. Or maybe it is. I don't know. But let's say we have a V1, right? So we have a specific like overwritten version of that. And so we're going to check the test case endpoint, right? So we make that request, and that's probably the one on our prod environment or in our staging environment or whatever. So then we deploy effectively another version side by side. We'll say 1.2.1 test case. We can go through, and we did this at Realtor. You know, we would go through our entire 5 million sale record, like list of sold records, for sale records, and basically compare apples to apples, right? All the way through. And that is where we found all of our weird edge cases that came from MLSs that we didn't expect, any sort of data discrepancy, like on write time. There was a whole bunch of things that we found by doing that. So basically we had like V1, we had V121 deployed side by side. We compared like every record in our database. We validated what was changed that we expect, what changed that we didn't expect. And then whenever we approved that API, we basically just set the V1 redirect to go to the new version, deleted the old version from the server, or you might keep it there as a rollback option. That made it really easy to do like canary tests and different things. But this is the way that I've seen it work most effectively. So if you're in this state, it might be a good idea for you to start looking at version over version testing. We'll get to behavior-driven tests in a minute, but I want to show a few examples of how this can work. So we have version over version testing. This is something that basically a way that I put it together just using code. And then I'm going to show you another tool called approval tests, and I'll try to make it pretty quick. So in this particular case, we make our this one should pass. We make our REST request for 2010 0114. We have a JSON document already set up here. That's exactly the way we set it. So this was the previous good test run for this particular endpoint. For this particular GET request, this is a valid output. And let's say we released yesterday to our test environment, and we don't expect it to change. So basically, we assert true that compare objects. We pass in the response here, which is our actual. We have our expected, which we're going to read from this JSON output, and this is going to be the name of our test. So let's see. So we run that test. It's going to go through, and we will jump into that in just a second. But we actually sometimes, we want to make sure that it fails, right? So we're going to, sorry, it took a little bit of time to build. So it took 492 milliseconds for that to make that test. So if we're running a whole bunch of tests, especially if we're running them async, we can just chug through a whole bunch of tests very, very quickly. So let's look at one that fails. So we're going to make this request again. I'm going to ignore this part for right now, these ignored fields. And we're going to assert true that we're going to use currency by date 2010-115, which is actually should be, I believe, exactly the same, except for the date is, we're expecting that to change. So we're going to run that test. Right. Okay, so that one failed. Okay, so we assert true, expect true, expect true, but we got false. So what this does is it writes an output here. So we have the actual JSON that we got. So if we were making a web request or something like that, we have the failed JSON, so we can look at that if we need to. Maybe that is actually the correct JSON that we want, the new baseline effectively. But we look here and we see that, oh, the key of date, we were expecting 2014, but it's actually, 2010, 114, but it's actually 2010, 115. So we could say, oh, well, that makes sense, right? Because we're looking at a different day. Or let's say that was a timestamp, maybe a requested timestamp, and we know that's going to change every time. So then what we can do is we can just ignore that particular field. So in this code, we have a list of string, which is our ignored fields. So we just add that to the request here. We're going to run that again. In which case it looks for that, and if it has the key of date in that field, it will ignore it, right? So in this case, it passed. But let's say we have, a whole lot of failures. So in this new object currency by date, this one I've changed some of the, I've actually removed I think it was Hong Kong, and added ABC. We have a different date, and I think Canadian was changed in that one. So we're going to run that one and kind of see what that output is. And again, if this is something that it's not specific to any API or anything like that, so it's in this, in the code, you'll find that in the compare utilities. So you'll have the reading of cache JSON, saving from JSON, getting directories. None of that's proprietary, so you can feel free to grab that and use that if it helps you. So when we look at our, in this particular case, so HRK was removed from expected, right? So it's no longer there. ABC was added to actual in this particular case, but the values were, were the same for everything else. But if you notice, we ignored the fields for date. So in this particular case, like, we knew date was going to be a problem, so we ignored it. But these, it would be an actual bug. We could then take that and say, hey, I'm going to look through it now, and this is what we got from our API. Since we already have the our baseline, this is the actual result that we are comparing against. We see now that, oh yeah, HRK is there, and ABC, which we were expecting, is missing. So now, what if you don't have these already? Maybe it's the first time you're running that test. Let's see. Oh, this is sorry. This one is a way of testing it, like, with two APIs. So in this case, if we were to test 2014 and 2015 and compare those results. So this is actually would be an example of making two REST requests rather than using your JSON, your already saved JSON document, which should fail for us. There it is. Compare versions, right? And so then it's showing us all of the changes that we, in this case, we were expecting those changes because it wasn't the same one, but it's an example of using two things. Now, also in this case, it's going to do a whole lot of compares. And this is what I was saying about making a request, getting some data, and then validating that response later. So in this particular case, we grab a REST request. We then we'll take that into a rates object, right? So this is our deserialized object that we have from above. We say, give me every item in the rates dictionary, and then make a request. So we're going to look at 2010, 114. I picked that date because it was just the example one, and put base as, so it'll be base as Canadian, it'll be ruples or whatever, right? So it will basically make a request for each one of those. In this particular case, we have a file name and its currency key. In this case, we're going to say, like, go try and read the cache JSON. If it fails, we're going to save this JSON document. because right now we only have these 3, and this is going to put out a whole bunch of other ones. And then if expected here, which we grabbed, does not equal null, then we assert true. So in this particular case, we're going to run it. It should fail and then save a whole bunch of baselines for us, I believe. Or at least it was at one point. And then once we, well, of course, it's not going to work whenever we get on the thing. And then when we run it again, once it actually saved all those baseline files, which I'll need to figure out why it wasn't. But right now, it basically should be trying to read that file name, not find it in cache response, and then save it. Unsure why that's happening. I'll check that, but that's the idea. Now, if you want to see a tool that actually works, anyway. So we have another tool called approval tests, right? So they have this for several different like actual APIs for several different languages. They have it for Java, they have it for C#, and I was actually already doing some of this with our internal teams, and then I actually saw Angie Jones posted this, and it's kind of a neat little tool to use that. So it's very, very similar. We're going to make this request, and you'll see like we've got this approval tests with version compare. So we have a couple of those that we're going to do. Let me just make sure. We're going to start with this one. And this actually takes a string whenever we run these tests. So whenever there's a failure, in this particular case, right, because we removed the scrub data, this is saying this is what we're expecting. This is the exact output that we're expecting. In which case at the end, it's expecting pound date, but instead it is getting this date. So let's say this was the one that we wanted to keep. We would say use this whole file, save it, and that is now our new baseline. In this case, we actually wanted to use, which is why I grabbed this. We knew that that date was going to be different. And so this is already saved here. You'll see these files saved over here on the side. These are what approval tests uses. And so those need to be present for this to function. And so in this particular case, we are going to update that with the dynamic content. We are then going to run it again. And as you notice, this now passed. Didn't show the little GUI that we saw before. And it has, and it's fine. So if we didn't have these, so let's say I'm gonna, and also you'll notice that now that it passed, it actually removed the previous copy. So basically this is to show us kind of the updated version. If we don't have anything in there and we make the test run, it will actually show us, the first time it will show a failure. It'll say that you don't have any, or whenever it's not saved, it'll say, oh, you don't have anything at all. Over here, this will be blank. You just say, like, let's say this is our new baseline, in which case last time we ran it differently with different numbers. Let's say this was the correct one. We're going to say use this whole file. This is the new one. We're going to save it. And then we're going to run that again. And it's going to remove the previous failure, right? So this is a way of basically, this is something that was really easy to import. Literally just grab the approval tests NuGet package, use this use reporter type of diff reporter, and then approvals.verify. Again, the first time we did that, excuse me. If we were going to, let's make a new one of test. Let's save that. We should see another one pop up over here. run it for the first time, even though it's basically the same as the other ones, it's a different name. So that's how we store that. It says, okay, we don't have anything here. So this is our first baseline that we set. We, again, use this whole file, save it, and then run it again. So this is a really cool tool. Something that I found was, kind of a really neat way of doing this kind of testing. One of the things that I have found, though, is I was looking around. As long as you know it's going to pass or fail, it's fine. But whenever you're using it in CI, you don't really have the option of saving those new baselines. So that's one of the limitations here. It's really good to run it and be able to see the differences. But since it saves those baselines, but again, you might see it in, these actually get checked in. So if you see that, whenever you check in your project, it checks those in. So if you see it, fail in Jenkins, for example, you pull the code, run it, save the new baseline, upload it, to your Git repo when it's done. So a couple quick, one last thing is whenever I was looking around a lot, I saw, just trying to, get some ideas for my talk. And there was a lot of behavior-driven API tests, right? So Cucumber, gherkin styling. So should you use it for API tests? Obviously, if it's mandated by your company, there's not much you can do there. But as far as I'm concerned, BDD by its name and definition do not lend itself to API tests. So this quote here was that at the highest level, software development is just a way to support human behaviors by automating, replacing, and creating them, right? So every behavior should change, should help the business, whatever. So the whole point is talking about business, right? So when we're talking about is about behavior, right? I don't ever recall seeing users generally going and checking the status code of their request. So this is one, just an example of that I found out in the wild on one like a Medium article or whatever, and there's a whole bunch of these I receive a valid response, I receive a 200 code, I receive a 200 code, whatever. Like that is not user behavior. And so if this is the kind of test that you're doing, the kind of test that you're writing, and the kind of test that you're running, it doesn't really need behavior driven. Business analysts, product managers, they don't care if it's a post request, a put request, a get request, a delete. They don't care. And they don't necessarily care what response code it is. I mean, it could be a 300 redirect. For all they care, they don't know, as long as the behavior flow works on the front end. So it's not necessarily, for our API test, that shouldn't necessarily be, what we're doing. It also adds an extra layer, and actually, in my opinion, decreases the readability of the tests, especially if we keep our tests nice and small. And especially when you're doing anything other, like, okay, this is fine, it's 4 lines long. Could you do it in 4 lines? Maybe, maybe not. Most likely, yes. I think we did it in 2 on the previous one. But it actually decreases readability whenever you're doing a whole bunch of validations in those. So it really just adds an extra layer of abstraction. You have to have your feature files, your spec files, and then your step files and all this stuff, that are going on to make this happen, on top of all of the code that actually does the heavy lifting. So basically, in my opinion, and again, this is just my opinion, don't do it. It's just my opinion, but I will fight you over it. No, I'm just kidding. But for real. But I'm mostly kidding. But mostly for real. So anyway, so those are kind of my thoughts on API testing. Are there any other kind of testing patterns that you're using for APIs or tools that I didn't cover? Or do you have any questions for me?
Can I ask one clarifying question, Joel?
Of course.
You said something early on. You said something about Swagger, that that it represents what the API does do, not what it should do. What can you clarify that?
So generally, what happens is when we, it basically uses the code of kind of like the backend code to build its to build its documentation. And so when you make changes to that, it would then update the document, which makes sense, right?
Gotcha. So
That's
you're
what it's
talking
supposed
about
to do.
Swagger that's auto-generated from the client or the server code.
Yeah, and
Okay.
in my experience, because nobody wants to do extra work and generate it again. Generally, it's just
Sure.
like they're like, this is it. Go to the go check Swagger, but then it changes with their changes. But yes, you can do that and save it other places and actually have a legit data contract. But that's what I'm saying. It works. Just be careful how it's done.
Yeah, that makes sense.
Good question, though. Any other questions? If you have any, and you think of it later, or if you're going through, watching this again, you can find me on LinkedIn. Send me a quick message, or if you just want to talk about kind of API testing stuff. I enjoy talking about all this. But and also, if you go on my GitHub, if you can find all the code that I'm using here. Again, use it if it helps you. That would be great.